All right, so I guess we'll start the review session. Thanks everybody for coming. 26 viewers. That's a record this year, so good job. Lots of questions in the chat. Um, Hopefully the volume and everything's coming through and the screen sharing is looking good. So just write your questions in the chat and I'll get to practice problems after that. Yeah, definitely remember you, Young Shroom, from previous semesters. Welcome back. We're going to do some introduction to chemistry review today, so welcome to stick around and ask questions on that if you have them, or whatever general questions you have. But I think most of my viewers are here for the review session, which I'm going to start just by sort of going over some content for the exam. So I don't think I mentioned in class, but you can expect the exam to more or less in content mimic the amount of time we spent on certain chapters. So chapter 1 we went through pretty quickly. It's covered on the exam, but it's not like the exam is going to be mostly chapter 1 material. Okay, so expect 2 to 3 questions on chapter 1 material out of 20 total questions. Right? Expect 6 to 10 questions on the PSS chapter, and then expect 8 to 12 questions on chapter 2, because we really did spend a lot of time on chapter 2. So half the exam or so will be chapter 2, those unit conversions. So I just wanted to get that out of the way. If this is your first time watching the stream, you can click the follow button at the top and turn notifications on so you can get an email whenever I go live for office hours or review sessions or just practice problem sessions. So we'll get to some of the questions in the chat, and then I'll work out some that I prepared. Remember, I told you in class that one of the problems I solved today in this live stream will appear on your exam. Okay, so one of the 20 questions or so, 18 to 22 questions probably on the exam, one of those questions will be one of the questions we do today. And certainly all the other questions we're answering, cover topics on the exam. So it's all good review. But I love to see the chat. It's filling up now. You guys are helping each other out with problems, so that makes me really, really happy. Move some stuff around here, and then we'll start going. And if you have to leave early or anything, remember I'll upload a portion of this session to YouTube later on. One easy question to get out of the way, specific heat. Yeah, we can review that. Shay Mel's got it right. Specific heat is how much heat or energy it takes to raise the temperature of 1 gram of substance 1 degree Celsius. Okay? And so just be familiar that different materials will have different specific heats. It takes different amount of energy to excite the molecules enough to change their average energy, right? Remember, temperature is just an average energy, whereas heat is sort of a total energy. Okay, so how much heat do I have to add before the temperature raises 1 degree Celsius for 1 gram of that material? Okay, so it's just a characteristic property of that material, just like a density is a characteristic property. Yeah, and if you lost the chat or exit and come back, you can always should be able to watch the video later on, and I think the chat streams as the video streams. So go ahead and type whatever other questions you have. All right, so I'll start with a couple myself. Remember, and I'll go through these kind of quickly, and then I'll get to your questions in the chat, because one of the ones I'm going to discuss today will be on the exam. So let's get to those. And we'll get to our problem solving emotes here. Okay, 325 inches cubed to volume in liters, right, was a question asked in the chat. We'll get to all those. But for now, let's convert some of these measurements. 528 gigameters to centimeters. Okay, so this is our straightforward dimensional analysis that we've been practicing for weeks now, right? What we're asked for in terms of units over here. There's my centimeters, terribly written. On the left, I'm going to write down 528 gigameters. Capital G for giga, lowercase m for meters. And then I have to convert these things, all right? And so I'd encourage you to write down at the bottom, if you get a question like this off to the side of the page in your exam or whatever, the unit factors, right? That you'll have to have memorized the relationship between gigameters and meters. Okay, 1 gigameter is 10 to the 9 meters. And then we're going to centimeters, so I'll write down 1 centimeter is 10 to the negative 2 meters. Okay, so now it's a matter of organizing these appropriately. Obviously, I'm going to use this first unit factor to cancel out gigameters. And I'm going to write this kind of quickly so that we can get rid of or get through a lot of problems here. So excuse the writing, but I want to get through a lot of practice problems for you guys. The second unit factor I'm going to use in the second set of parentheses to cancel out my meters and leave me with centimeters. Going through and making sure all my appropriate units cancel, I'm left with centimeters. And multiplying across the top, dividing by the bottom. Remember, make sure you're using your calculator, your scientific calculator, and you understand how to enter 10 to the 9. Sometimes you have to use a little EE button or EXP button on your calculator, so make sure you're using that and doing it correctly. For anything in the denominator, like this 10 to the negative 2, I would hit divide, open parentheses, and then enter the 10 to the negative 2, close parentheses, enter. Just to make sure all of that is getting in the denominator as you intended. Okay, so this, I think, should turn out to be, without actually doing the calculation, the calculator 5.28. You can go ahead and type in the chat if you know the answer, or if you're calculating along. I'm just going to see that it should move the decimal place 11 powers of 10 to make this 5.28 times 10 to the 13 centimeters. Okay, so somebody in the chat confirm whether that's right or not, and we'll move on. Okay, let's add 2.3, 2.303, and 101.50269 and round off the answer. This is obviously a sig fig question, otherwise you're just entering this in a calculator. All right, thanks. Looks like the chat confirms that previous answer, so we'll go ahead and say that one's good. So entering these numbers in my calculator, I get 106.1056 9, and then I have to remember the rules for addition and subtraction, right? And it's go out the least number of decimal places. This is the tenths place, this is the tenth, hundredth, thousandths place, this is a bunch of decimals. I can only report out to the tenths place since one of these answers was only out to the tenths place. Okay, so I look at the hundredth place, it's a number less than 5, so I just round down and leave it as is, 106.1. Right, should be the correct answer. Yeah, Hart says 5.28 times 10 to the negative 13, but it should be a positive exponent. There should be a ton of centimeters because those are really, really tiny things, so there better be a lot of them in 1 gigameter, which is a really, really big thing. Right, so I think it should be positive 13. All right, cool, so maybe he just typoed for her. Okay, so that's the answer for this addition subtraction. Let's try multiplying because the sig fig rule is different. When I multiply the numbers now on the screen, I get 529. If you have questions on these, just pop them in the chat as we're solving them. If you have your answer, go ahead and guess it in the chat. so I can get some feedback for how you guys are doing on these. I get 529.69, but obviously now I got to round off and use my rules for multiplication division here. What do you guys think? Where should I round this one off? Rules for multiplication division are different, right? So I go out to the least number of sig figs now. Nobody's brave enough to guess in the chat, huh? All right, we got 529.7. Anybody want to 530, 520, 530? All right, lots of them. Forget that this is on a little bit of a delay, so I got to give you guys a little bit of time. 530, 500, 530 star. Oh, that's a changed answer for Blocksmith. The power of persuasion from AJ McGee. Alamuha. One person is correct so far. Still only one person correct. So let's count sig figs. 2.3, 2 sig figs. 2.303, 4 sig figs. 100, 1 sig fig. All right, so I can only report this number out to 1 sig fig. 5 is the first sig fig. So I have to drop the rest of the sig figs, but I can't just report 5. So I have to use placeholder zeros and report 500. Oh, right. There's the light bulbs in the chat. So that one's kind of tricky. I don't think we haven't done one kind of tricky like that in class, but that's a good test just to go over the rules for counting these up. All right. An Indy 500 car can travel 111 meters per second. What is the speed of car in miles per hour? Okay, so some people earlier in the chat were asking for these kinds of dimensional analysis problems, so hopefully this is a good test. Yeah, you can't just report 5 for the previous answer because that loses out that it's such a large number, so you got to have the zeros in there. They're not significant in 500, but they got to be there. What is the speed of the car in miles per hour? All right, so we'll go for miles per hour over here. Do I have a little car? Do not have a car. We'll pretend that's an Indy 500 car. Miles per hour. And like you'll expect on the test, I'll give you here included these metric to English unit conversions like kilometers to miles. This one I expect you to know, but I probably will give it to you anyways. 1 hour is 3,600 seconds, right? That's just because it's 60 seconds in a minute, 60 minutes in an hour, so 3,600 seconds to an hour, right? So I'm sort of saving you one step in conversion by just providing you this here. Would there be a displacement problem as well? I don't know what that means. Rephrase that question. We'll be given that note on the exam. Yeah. So I'll give you this kind of note. So we're given 111 meters per second. And remember, when you see it written like that, meter/second, that's obviously meters per second. But write it out in terms of your units and setting it up in this manner, like I am on the screen. Kind of like our unit factors are, meters over second. Okay. And as a review, that you don't have to write this, but this is really per 1 second. Okay. We don't really write the 1 because anything divided by 1 is just itself, but it means 111 meters per 1 second. So that's looking more like a unit factor, but that's the unit factor we're starting from. We obviously have to go from meters to miles. And so we're going to use this unit factor, which will allow me to cancel miles first. Exam's going to be about 20 questions. Could be 18 to 22, but you can see the practice exam is 20. That's a good benchmark to shoot for. To get rid of this meters, I know I'm going to need meters here, but none of my given information says meters, right? What's given is miles, okay? So don't confuse that. That's not the prefix here for meters. That's miles, right? I need to get rid of meters, but I'm going to go ahead and remember that in 1 kilometer, there's 10 to the 3 meters. Okay, how did I know to use the relationship with kilometer? I know I have to get rid of meters. I might as well go to kilometer since that's a unit I'm given in the problem, right, as one of the next units. So that now I can use that given information to cancel kilometer and go to miles. Okay, so hopefully that makes sense. So I'll put my 1.61 with kilometers because that's what I'm told in the note. I'll put the other half of that equation in the note and the other half of this unit factor. And now that I have miles in my numerator, I'm done with the numerator. That is going to correspond to what I need at the end. I now need to get to hours here from seconds. Okay, so seconds is in the denominator here, which means it better be upstairs in this unit factor to cancel out. Hours in the denominator in my final, so it better be in the denominator in this unit factor. And I'm told in the question 1 hour is 3,600 seconds. And now I multiply across the top to get $248.198.7, etc., etc. Okay, and then I'm going to look for sig figs. I'm given 3 sig figs in 111. All my unit factors here is 3, 3, 3. This is technically 4 because I wrote the decimal place after it, making these zeros significant. Okay, although as I told you in class, look back in your notes, these inexact relationships, well actually that doesn't count here because this is an exact relationship. 1 hour is 3,600 seconds. So this doesn't even matter in terms of sig figs, okay? But even so, I specified 4 sig figs in the 3,600 seconds so that it wouldn't come into play. That was just how I set it up. So definitely want 3 sig figs in the final answer because it's all multiplication division, and there's 3 sig figs given, 3 sig figs in this unit factor. This other unit factor is a exact relationship. So limited to 3, this all drops out. I should get 248 as my answer. JMail wants 1,000 questions on the exam. That can be arranged, and you just get through as many as you get through, and I'll have to have quite a curve on the exam. And I will curve if there aren't a lot of people that get perfects, but usually there's a handful that get 100%, in which case I'm not going to curve. But if there's only like one person that gets 100, I'll curve a question or two. So anyway, we can check the answers in the notebook. Yep. In the workbook, flip ahead about a couple pages. So for the practice problems, there is an answer key for the practice problems. For the practice exam, there should be an answer key at the end for them as well, I hope. Yeah, it's on the last page. Yeah, the answers are. Yeah, AJ, that was the answer to the first one. All right, so let's keep going here. Again, keep putting your questions in the chat. And we'll after I get through the ones I have prepared here, we'll get to your specific questions. Right, 0.00040000 in scientific notation. All right, so let's first approach this by seeing what's significant and what's not. I think Arth might have been freaking out about the 1,000 questions, but I won't do that. So that's, before we put in scientific notation, we know scientific notation just writes the significant digits in a certain format. So which ones are significant here? The leading zeros are never significant. Okay. The first significant digit is 4 here. The trailing zeros are significant like this after a decimal place. Okay, so there's 5 significant digits here. The first one is 4, so scientific notation is going to look like 4 point, and then followed by the other significant digits, which are the 4 zeros after it. Okay, because all of these are significant. The leading zeros are not. And now I have to see that I've moved the decimal place 1, 2, 3, 4 places to the right. This should be 4.0000 times 10 to the negative 4. All right. So let's see. Oh, volume displacement. Okay. In terms of like measuring, I guess, like the only thing on the slide we really talked about was, using a graduated cylinder and reading different things. So, you know, the only way I could give that question is showing you a couple different pictures of graduated cylinders, and you would have to subtract the amounts. So, I mean, you need to know about that concept of how to get volume. Whether it's on the exam or not, I can't really tell you, right? There's only 18 to 22 questions. Okay. We'll do a percentage problem. I think some of you have asked for this, so maybe not this exact question, but similar types of question. So let's look up, or let's figure out here how to solve a percentage question. For these not super expensive metals, but they have some value in them. And this metal block is tin and misspelled copper there. Just fix that. Bam. Tin and copper. Oh, although I guess the previous emoji or background will work because that's a copper right there. If the block is 42.4% copper and consists of 24.3 grams of copper, what is the total mass of the block? Okay, so as soon as I see a percentage, I'm just going to write the formula for percentage. I know it's one thing divided by total times 100. And so here, if I want percent copper, okay, it's going to be the amount of copper, in this case, grams of copper, over the total grams. Okay, hopefully it's not buffering for everybody and it's still, the video is still working. If not, or you missed a section, remember I'll upload it, or you can watch it later on Twitch as well. So now I'm going to fill in the numbers I'm given, 42.4%. Okay, and I'm also given 24.3 grams of copper. Right, and so I clearly have to calculate the total grams of copper. Okay, I'm going to go ahead and give you a cheat here, pro tip. If rearranging this equation looks intimidating to you, okay, because it's just an equation. You used algebra to isolate, the question mark here and calculate according to basic algebra. But if that's intimidating or you're afraid you're going to mess it up, right? It's a multiple choice exam here. So pro tip, you can try each of the multiple choice answers in place of the question mark and see if the percentage you calculate out is 42.4%, right? Because one of the answers is correct. And so 24.3 divided by multiple choice answer A times 100, does that equal 42.4? Or close enough with rounding? And that could be the answer, right? So you can eliminate a lot of answers by this backwards math. Okay, so all right. All right, sweet. I wasn't sure if the video stopped or not. What he said buffering, so thanks everybody. So the other way I can solve this here is isolating for this question mark, okay? And if you have something in the denominator like this, right, and you want to solve for it, you have to get it in the numerator and by itself, okay? So the easiest way to do that, at least how I think about it, is I need to move this upstairs, okay? And that means taking and multiplying it on both sides of my equation. Multiply the left side of the equation by total amount of grams, right? X total amount of grams, or question mark total amount of grams. Because if I multiply it on the right side, grams total, that'll get it to disappear here. And then it'll appear in the numerator on the left side. In which case it'll be multiplied by this 42.4%. All right? And the right side of the equation is then just 24.3 times 100, since that denominator got canceled out. All right, this is just basic algebra here. I have to isolate that question mark further. I have this 42.4 here, so I better divide both sides by 42.4. Now it'll drop out on the left. There it is on the right. And now I've isolated question mark equals 24.3 times 100 over 42.4. And I get 57.3 grams, rounding to 3 sig figs. So that's the total amount of mass of the block, 57.3. Yeah, it must be your internet connection, Hart, because it seems to be working for most other people. Okay, so that's all the practice problems I prepared. There's the percentage one we just did. Remember, pro tip, for a lot of these, if you can set it up, you can try different answers and try to back work your way to a piece of given information here, right? Like we could try to calculate 42.4 by trying each of the multiple choice answers in question mark grams total, right? So that's just an extra strategy if you get stuck on a problem. Lindsay asked, but you would divide by 0.424, right? Since it's a percent. In this case, no, because I have this times 100 here, okay? If you're using a formula where you want to write 0.424, that's okay, but then you don't need the 100 on the right, okay? So if you divide it by 0.424 here instead of 42.4, you shouldn't have the 100 in the numerator. Okay, so 57.3 you'd still get if you did 24.3 divided by 0.424. Yeah, it just depends on how you think of percentages. I was sticking to the formula there. So yeah, I think your way will work just fine. So do what's best for you. Scientific notation. So there's just some of the practice problems I think people often mess up. So I wanted to go through some of them. All right, so let's get to what are the questions we have here. And I'll start at the top. If I did, a similar question to one that was asked, I'll probably skip your question. So no offense, but if it was a very similar percentage type question, I'm not going to solve one unless I have time at the end. All right, so let's start to look back up here and see what you all were asking. 25, and if you've since got your question answered or figure it out, tell me to ignore it. Ashley has 325 cubic inches to volume in liters. (92.5% silver and 1.5 grams copper). How much silver is in the whatever you want, whatever it is, necklace? We have 40 viewers. This is great, guys. Keep posting your questions in the chat. The more you're asking, the better I know what kind of problems I should solve. Sorry, I missed this one here, but to what power conversion do we have to have memorized? All of that table, right? Go back through make sure you're going over the slides, right? Go back over the slides, and it clearly says memorize this table. Well, the table has exa all the way down to atto, okay, in this version of the book. Yeah, so it's kind of blanking out there, but so it's exa, peta, tera, giga, mega, kilo, deci, centi, milli, micro, nano, pico, femto, atto. Okay, I need to make a wrap up about that sometime. And yeah, I got bars. So make sure you know all those prefixes and the relationships. If you just want to commit them to memory and the first thing on your exam is you make that table so you can use it for the rest of the exam, that's fine. The paper exam that I'm going to give out is yours to keep. I'm only going to collect the Scantron, so as soon as you get it, you're able to write all over that thing, okay? So that might be something you want to do. Okay, what else here? Let's see what other questions. An addition subtraction question. Adding two numbers together, why would the answer be 19.44? It's because addition subtraction, right? It's the number of decimal places, not the number of significant figures. So you go out to the hundredths, since 7.77 is out to the hundredths. So we don't have to know the one above exa. No, it's not in the book, just that chart. Chapter 2, practice problem 8. Two of you asked about that. Oh no, somebody solved it. So yeah, we'll do something similar to that. I think somebody asked about it. Water percentage. There's that one. And yeah, I might not solve the, well, no, didn't I write it here? Yeah, we'll solve that one anyways, even though it's sort of solved in the chat there. Oh, welcome back, Hearth. Sorry you missed the entire previous segment. I gave all the answers to the exam out for free, and everybody that was here got extra credit except you. Feels bad, man. Right, don't worry, you can go back and watch it later, right? As long as your internet connection's good, you can watch the stream later. All right, so let's solve some of these. Keep posting them in the chat. I'll probably have time even after going through these to solve more questions. 325 cubic inches to volume in liters. And now I will probably, if it was written like this, I'll go ahead and give you that. You're welcome. Merry Christmas. Happy holidays. 1.00 milliliters equals 1.00 cubic centimeters. Given 325. Need to get over here to liters. Oh, I'd also have to give you something else, wouldn't I? Oh. Hey, thanks for the sub, Arth. So 325 inches to volume in liters. Rewrite this out. You do have Twitch Prime. You can link it to your, or if you have Amazon Prime, you can link it to your Twitch account, and that gives you one free subscription. Okay, and when you sub, the video maker, you know, can make the chat subs only. You know, I open it up to everybody. We're not that exclusive here yet, but thanks for the subscription nonetheless. Cool. Inches need to get to centimeters cubed in order to get to milliliters, right? So you should have the roadmap here. Given inches cubed, going to liters. Well, there's milliliters are given, so you know you're going to have to go through that. So you might as well at the bottom, right, write out that 1 milliliter is 10 to the negative 3 liters. Right, that's probably going to be useful. There's cubic inches. Here's centimeters to inches cubed. That should give me everything I need. And I'm going to do a little bit of a shortcut here. Thanks, Adobe. Popping up. I know I'm going to have to get rid of these inches. So I'm going to use this unit factor I have that includes inches, 2.54 centimeters in 1 inch. That's only going to get rid of one of my 3 necessary inches. And I'm just going to write cubed around this unit factor, right? Which signifies that I'm doing it 3 times. My computer's freaking out here. So the stream shuts down, I'll be back, but hopefully it won't. Okay, so I'm going to write that cubic sign there to signify that I'm going to do that multiplied out 3 times. That will get me from inches cubed to centimeters cubed. And then I can get rid of centimeters cubed. Milliliters. Okay, and I want to stress that again. This cubed right here means I write out 2.54 centimeters per 1 inch 3 times. So I'm going to have to multiply 325 by 2.54 times 2.54 times 2.54. Okay, but that's the same as writing 325 times 2.54 to the third power. Okay, so it's just a shorthand to save some space, but that is a cubic centimeter. That'll cancel that cubic centimeter. Now I'm in milliliters, and now I can get from milliliters to liters using the unit factor at the bottom of the screen here. Okay, so 325 times 2.54 times 2.54 times 2.54 times 1 times 10 to the negative 3. I get 5.326. I rounded there. I'm going to have to round this to 3 sig figs, so I'll write 5.33 liters. Yeah, you're going to have to know all the way to femta and exarth. Right, that's what's in chapter 2, table 2.2. You actually have to know the ATTO, A-T-T-O. That's what's shown in my table. And it should be the one in the slides. Hey, let me see here. Yeah, that's in the slides. So on slide 6 or so of chapter 2, where it says commit these to memory, that means commit that whole table to memory. Okay. And I also show you later on like the metric equivalent inches to centimeters, and I say these will be given to you on exams. Right? Just so there's no, it's perfectly clear everything we have to memorize. All right, so 5.33 liters should be what I get here. 43 viewers, that might be an all-time high. All right, where we find an approved calculator list. Also, I think in the slides? Question mark? Let me see. I definitely showed it in class. I don't think it made it into the slides, but it's non-graphing, non-programmable. I'll show you what's not allowed is these big ones. That has like this big display here. So it'll have a tiny, thinner display. Send me, take a picture of it, or then do a Google image search and find one that you're thinking about buying, and send me an email and say, is this one okay? And I'll say yes or no. How do you put that equation in the calculator? I'm getting the wrong answer. Okay, AJ, the one we just did here, I would do 325 times 2.54 times 2.54 times 2.54 times 10 to the negative 3, right? Because that to the third power here means there's 3 of those 2.54s. So, right, we canceled out the unit centimeters cubed. Good question. We canceled out the unit centimeters of cubed, but that cube is outside the set of parentheses, so everything in there is getting cubed, the number and the unit. So yeah, I really should just write this out 3 times rather than the shorthand, just I was going to run out of space. So it probably makes more sense instead of inches cubed to write out inch times inch times inch. Whenever you see something like inches cubed, And that way you can use the unit factor and use 3 of those unit factors to cancel out each inch and leave you with each centimeters. The inches cubed cancels out because, again, this superscript 3 right here is attached to everything inside the parentheses, okay? Which means it also is this 1 down here gets cubed, but 1 times itself is still 1. The inch down here gets cubed, so it's inches cubed. Okay, so if it's confusing you, it's because I used this sort of shorthand, and really it probably makes more sense to not use the cube to save space and just write out 2.54 centimeters per 1 inch, but have 3 of them here, because I'm going to need 1 for each inch to get rid of. Okay, so here's the longer way. Of it 3 times. Okay, all of which these 3 inches then would cancel all 3 of the inches cubed, and I'd be left with 1, 2, 3 centimeters, and all 3 of those will get canceled by the next unit factor, which is 1 mil per 1 cubic centimeter. Okay, so hopefully that makes sense. And then the last one there is I still have this 1 milliliter for 10 to the negative 3 liters. I'll come back to this percentage one if I have time. We've done a couple like that percentage. Another percentage. Oh, all your questions are percentage questions. Okay, so yeah, we should do these. The moon is 4.7% iron. How much iron is in a 92 gram moon rock? And that should be a question mark, obviously, not a period. Question mark, right? Come on. As soon as I see a percentage, I'm going to write out that percentage, but in my percentage formula, I know a percent is a ratio times 100, and what's in that ratio is the amount of the component. Here it's iron. The unit is grams. That's the unit I'm working with here. So it's grams of iron over total grams. What's total? The moon rock. Right? Because the rock has iron in it. Okay? How much iron? Well, that's what we're trying to figure out, is in 92 grams moon rock. Okay? So now this is a algebra problem. Okay, try to get the question mark alone. It's in the numerator already, which is good. I need to get all the other numbers, though, on the other side of the equation, so I'm isolating this. I have a times 100, so I'm going to divide both sides by 100. It cancels out there. It appears here. I have a 92 down here in the denominator, so I'm going to multiply both sides by 92 grams. We'll cancel it out here. But I need to also multiply the left side of the equation by 92. And so now my question mark is isolated. The equal sign is still in place, and I do 92 times 4.7 divided by 100. Beautiful writing, Dr. Melko. Clear as mud. And here I get 4.3 0.324 grams. I'm going to round this to 2 sig figs because that 92 had 2. All right, I'll do one more percentage question, and then I'll do a density question. Doing conversions is safe to say when we go from bigger to smaller, the positive exponent, and smaller to bigger is a negative exponent. Okay, I think what you mean, if you go from a unit that's higher up in the table or a larger unit, you're going from that to something lower in the table. The final answer will be a larger number than the number you start with. Okay, whether it's a positive exponent or not kind of depends, because if you start with 0.000001 kilometers and you're going to centimeters, your final answer might still be a negative exponent because you haven't moved the decimal place enough to get to positive exponent territory. But your final answer will be a larger number than 0.000001, okay, because you're going to a unit that is tiny. So there needs to be a lot of them compared to the large unit, right? Because one large unit is a whole lot of little units, right? One case of lemonades is 24 lemonades. A case is a large unit that contains a lot of small units. All right, water is 88% oxygen by mass. What mass of water contains 49.5 grams of oxygen? I'm going to write this in my percentage. And yes, lemonades are definitely sold by the case. I have confirmed. It's a nice day for a cold lemonade today. Refreshing. 88.8% oxygen. And I see that percentage. I'm going to write this then out. 88.8% equals ratio times 100. Grams is the unit. So what mass of water contains? So water is the total. The component here is oxygen. So there's 49.5 grams of oxygen and some total amount of water. So we have to solve for this. Okay, so this is the algebra problem we talked about before. But again, look at your multiple choice answers on the test, put them in here for the question mark, and see which of them give you 88.8%. Okay, but to do it the algebraic way, I need to get this in the numerator. Okay, I'm going to multiply both sides, which is the same sort of as cross multiplying here. Right, if you'd rather do it that way. Cross multiply, you get 88.8 times question mark. Cross multiplying the other side, you get 49.5 times 1. Okay, now I need to isolate the question mark. I'll divide both sides by 88.8 because I need to get this number away from the question mark. And so my final answer, the question mark, is going to be equal to 49.5 times 100 times 1 divided by 88.8. And I get 55.7, I think. Okay, so we'll do a density problem. Volume displacement problem. Yeah, I answered that earlier that we need to know that concept for sure. Okay. The fact that you can use maybe a graduated cylinder filled with liquid, measure the volume before and after, and the difference is the volume of the material, right? So if I started with 50 milliliters, I put the material in and it went to 70 milliliters, then the volume of the material is 20 milliliters. Okay, that's all you need to know for volume displacement.